Good morning, good afternoon, and good evening all. This is just a prediction on the problem that we are currently having, which is coronavirus. A prediction is not a reality. I just thought of coming up with such a model just to show you how serious this can be if we all don't be serious or we don't adhere to the guidelines that Ministry of Health is giving us. This can be very, very dangerous. So last time what I did, if you are to go to my YouTube account, you will see my prediction based on Monte Carlo simulation. Today, it's going to be different. I'm going to use exponential model to predict the worst case scenario if we don't take this issue seriously. So this is how we will do it. First, we'll need to come up with one assumption on assumptions. Modeling is about assumptions. So assumption one will the model assumes that the vaccine what's the spelling of the vaccine? The model assumes that the vaccine will be administered at the end of July, at the end of July 2021. Just check on the spelling. Okay, it's okay. This is a major assumption because with the exponential model, you cannot keep on. You need to actually come to a stop at some point. Okay. So these are the cumulative cases. Cumulative cases. By the way, this is Zambia. So the cumulative cases, meaning the active cases, or no, new cases, not active. That's 0. So these are the new cases. Just put in the decimals. Okay. We can then show the percentage increase. I guess this will be 0%. Can start from here. Okay. So is this deadly? Is it the deadly or the new corona strain? Where you can see that just in December, we had an increase of 150%. Okay. So we have these numbers. So I've been told as of 31st December 2020, 20,725 cases. Out of that, 392 died. recoveries to 18,656, and the currently infected is 1,677. This is as at 31st December. So we can now do our modeling. So we can show from January, February 2021, these are months, up to June, because we're assuming that by June, we'll have the vaccine. So expect the exponential growth to slow up at that time. That's the assumption of this model. So I'll do like this, then we'll show new cases. So the second assumption will be on the growth. So the growth of this pandemic will peak 150. This is the worst case, not the worst case. This is, how would I say, the most neutral, the most neutral assumption. So I'm getting this 150% and dividing it by 2. If I were using Monte Carlo, then I would pick this. I could still go and show things like, for example, the mean. If I was doing that, do like this. I'll go to the standard deviation. So I'll pick all this. And I could then now do my Monte Carlo, where I say equals norm this. Sorry. I could pick this and do my Monte Carlo random and do like that. Come to mean, do that. Come to standard deviation, do that. Change that. I could do all these things, but then in here I can put in a max mean so that it doesn't give us negatives. But there's no need for now. Since I'm not doing Monte Carlo simulation, so there's no need for that. So I'm saying the growth will be 79%. I've just divided 150. You can still have anything, but from the statistics, it's showing me that in the month of December was 150%. So I decided to divide it by 2, just to minimize the impact maybe. But the worst case scenario, I would put 150% here. 3, what would be the other assumption? Or the other assumptions will be on these months. So then now I can do this. I'll pick the base. The base is 3780, which was the one that was recorded in December, the new cases, times exponential, that times the growth times the time. This is how you do it. Just the cases I don't want to show. Something that I haven't locked the base, sorry. Okay. So these will be the new cases, apparently. This is what we expect if we're not going to do anything, but it helps us in shaping policy and a change of behavior. So have that. So this is what I would do just to show you. If I was to plot that, this is on new cases. I have to put that. Come here. I wanted to edit the months. I can't. So this is what I'll do. I'll show here up to June. Okay. Okay, so this will be on the new cases. So we can then now come up with a cumulative. Show the forecast there. State this as actual. Like that. The new case says here. This plus that. Take it down. Like that. This can be, this will be a cumulative one, but I don't want to do such a thing and just remove this. I'll do like this. Come here, go there, and pick something like this. Cumulative cases. So if I'm doing this for policymakers, I know their area of interest would be on what would be the predicted number of deaths or new cases, at least for the new cases. They can then now start planning on how they can allocate resources in our health centers. We could even go deeper to show per town how these numbers will be broken down per town, per district, so that they can start planning. But again, what would be more interesting would be to plot something to predict the deaths if such a thing was to happen. Not if it was to happen. If we don't do anything, we do nothing, we'll do like this, just for planning purposes. And I'll say deaths. Hmm. Okay. So I'll check on the deaths in how many people died in November. Hmm. I have this data. I'll go to odometers. Sorry. So in December, there are how many deaths? 388. Then in November, 357. So 357 versus 388. So we have 357, 388. This is what I would do. Okay. So meaning on the deaths, what will be the percentage? Divided by that, which is just 9%, 8.7. So I'd use that, doing the same thing, picking the best, which is 388, bucket times exponential times the growth, or the growth times time. The numbers, they look small. This will not be best. This is not going to be the best. The best way to look at it. We'll do this. But look at the deaths. Would say if out of so we'll do like this based on this. This is what I would do. I would say out of the cases of 2017, so I'll pick the cumulative cases in January times the number of deaths I would log divided by the number of cases in December. Okay, like that. So this gives me an idea that if we don't do anything, this is what we'll expect, sadly, in terms of the deaths. Go like that. Yes. So one of the objectives of developing models is to help policymakers to come up with the proper policies. That is one of the objectives on how do we stop these cumulative cases that are predicted using statistical modeling predicted to go up to this level, um, up to about 200 or so, 50,000, 250,000. So how do we stop this to go up to 275 cases, which would take the number of cases to 537, predicted if we don't do anything, taking our mortality to that. So what are those things that we should do? That's the whole purpose of modeling. So please, let's mask up. Let's do all the right things. Just wanted to show you how you can use exponential models to predict the future. Thank you so much. And bye-bye. Maybe before that, if you need more lessons in modeling, customized in modeling, any type of modeling, whether it's deterministic modeling, stochastic, I'm very much available for you. Thank you and bye-bye. Oh, sorry, this is my email address. And my YouTube account. And it says you sit on my YouTube account, so you can just you can subscribe to our channel. Thank you so much again.